Happy Thursday, Kings and Queens. It is Thursday, October 29th, 2020, and we are going to move to Math 7 Unit 1, Lesson 10a. Just to jump right in, our classroom norms are that your cameras are to be on, your mics are to be muted, and that you guys are ready to learn. Your materials for today that you will need for class are your Math 7 Spiral Notebook. We are working on page 21 today, so let's make sure that we're capturing our notes on that page. And then also you will need a pencil and your student companion, which can be found in Google Classroom. So we're going to talk about probability again, but more specifically sampling. And it's day one of estimating probabilities through repeated experiments. So our standards for today are 7.sp.5, 7sp6, 7sp7b, and 7.rp. Our objectives are that students will describe patterns observed on a table or graph that shows the relative frequency for a repeated experiment, generalize that the cumulative relative frequency approaches the probability of the event as an experiment is repeated many times, and generate possible results that would or would not be surprising for a repeated experiment and justify the reasoning. Our mathematical practices for today are MP2 and MP8, which are reason abstractly and quantitatively, and to look for and express regularity in repeated reasoning. As always, please be ready to take notes and work collaboratively. And we will pause the video right here so that you guys can take down your standard and objectives into your spiral notebooks for today. Okay, moving right along, let's look at our goals for today. So today's goals are that we want to be able to explain whether certain results from repeated experiments will be surprising or not. We also want to estimate the probability of an event based on the results from repeating an experiment. So let's look at our engagement for today. So our engagement, which we will do inside of our journals, it says that we want to locate and label these numbers on a number line. And we have choices 0.5 or 0.5 tenths, 75 hundredths, 0.33, 0.67, and 0.25. So we want to label these on a number line. And then it says choose one of the numbers from the first question and describe a game in which that number represents your probability of winning. So we're going to take 2 minutes of quiet think time to do this into your notes. So you're just going to place these numbers where you think they go from least to greatest on a number line between 0 and 1. And then we're also going to be prepared to share your thinking. So we're going to take 2 minutes for you to answer this question, to put these points in order between 0 and 1 on a number line. And then we're going to share our thinking. All right, so to put these in order, I'm going to read the letter choices. You should have had E, which was 0.25. Then you should have had C, which is 0.33. Then you should have had A, which is 0.5. That should have been halfway through your number line. Then you should have had D, 0.67. And last but not least, you should have had B, which was 0.75. And then again, the second part asks you to choose one of the numbers from the first question to describe a game. And for me, a sample response could have been something such as when you get blue when randomly selecting a color from the primary colors, which is red, yellow, and blue, the probability would be 33% or 0.33 because you have 1 out of 3 chances. So that's what my example would have been. So let's look at your exploration activity. It's called In the Long Run, and your exploration activity can be found in your student companion. So at this time, let's make sure that our student companion is available. So let's read the scenario. It says Maya plays a game in which she only wins if she rolls a 1 or a 2 with a standard number cube. And we want to know What is the probability that Maya will win the game, and explain and show your reasoning? And we also want to know that if Maya is given the option to flip a coin and win if it comes up heads, what is the better option for her to win? So if I think about this problem when it says what is the probability that Maya will win the game to explain her reasoning, well, a standard number cube has 6 options, and but she can only win if she has a 1 or a 2. So that's 2 options out of the 6. If we simplify the fraction 2 over 6, that gives us 1/3, which means that she has a 33% chance of winning the game. Now, if Maya is given the option to flip a coin and win if it comes up heads, is that a better option for her to win? And we would say yes, because for a coin, there's only 2 options for you to win, either heads or tails. So there's a 50% chance. So in the first scenario, she would have a 33% chance. In the second scenario, she would have a 50% chance. Now, for the sake of time, we're only going to engage in part of the student companion, where it says to list the outcomes in the sample space for rolling the number cube. We're going to say that the sample space is 1, 2, 3, 4, 5, and 6, because those are our options. We already answered number 2 when it says, what is the probability that Maya will win the game, and explain your reasoning. And then we also answered number 3 about if Maya was given the option to flip a coin and win, what would be the better option. So let's go ahead and answer numbers 1, 2, and 3 in your student companion, just recapping what we just talked about, and then we'll come back together. Once again, for the sake of time, we're going to skip over the second portion of your student companion, which is completely fine, and we're going to keep moving. So, this portion, I want us to make sure that we capture it into our notes. It says a probability tells you how likely an event is to occur. So, it is not guaranteed to be an exact match. If the experiment is repeated many times, the fraction should get closer to the calculated probability. And the more repetitions, the more accurate the estimate. So the more you do something or the more you repeat an experiment, it's going to get closer to the probability that you desire. So now, actually, let me go back. So we're going to pause here just in case you guys have not copied all of this into your notes. So let's make sure that this is captured into your spiral notebooks. We'll pause the video here for about a minute to make sure that this gets into your journals. All right. So now let's move to our elaboration activity. Our elaboration activity is going to be called Do for a Win. It'll actually say explanation in your student companion. So that's where we are working at in your student companion. So it says the probability of a coin landing heads up after a flip is 1/2. So the probability of a coin landing heads up after a flip is 1/2, right? Because we know it's either going to be heads or tails. So it says for each situation, do you think that the result is surprising or not? And then we want to know, is it possible? And then be prepared to share your reasoning. So in your student companions for under number 1, where it says A, B, and C for explanation, you guys are just going to write surprising or not surprising, and then possible or impossible. So for number 1, it says you flip a coin once and it lands heads up. For B, it says you flip a coin twice and it lands heads up both times. And you flip a coin 100 times and it lands heads up all 100 times. We're going to take about 2 minutes for you guys to determine whether or not each one of these scenarios is surprising or not surprising, and if it is possible and not possible, and we'll come back together. All right. So for scenario A, where you flip a coin once and it lands heads up, it is not surprising. It's not surprising, and it is possible because that's an option for it to happen. Now, for letter choice B, when it says you flip a coin twice and it lands heads up both times, well, it's a little more rare than the first one, but it's not surprising, and it still is possible. And then for letter choice C, where it says you flip a coin 100 times and it lands heads up all 100 times, it is very surprising, in my opinion. So this one would be very surprising, and we suspect that the coin is not fair. However, it is possible. So this would be surprising, but it is possible. So for letter choice A, the first scenario, it was not surprising and possible. The second choice for letter choice B was also not surprising but possible. And then C, it was surprising but still possible. So let's discuss some things. If you flip a coin 100 times, how many times could you expect the coin to land heads up? Well, it should be heads up about 50 times out of 100, right? Because the probability is one half. So there should be the same number of heads and tails. And that's what you need to capture in your student companion for number two, where it says, if you flip a coin 100 times, how many times do you expect the coin to land heads up? Once again, it should be heads up about 50 times out of 100 because the probability is one half. So there should be the same number of heads and the same number of tails. Okay. For number three, when it says if you flip a coin 100 times, what are some of the results, some other results that would not be surprising? So something could be anything from like 40 to 60, or you can tell us what do you think would not be surprising. Okay. So we've talked about our chance experiment, what the probability of rolling a number cube was, and we're going to skip over that just for a second. This is another portion that I want us to capture into our notes, which is extremely important. Your probability represents the expected likelihood of an event occurring for a single trial on an experiment. So once again, we're copying this additional definition of probability in our notes. And regardless of previous tries, each coin flip should still be equally likely to land heads up as tails up. So we'll pause the video here so that you guys can capture this into your notes. Okay. And once again, we've talked about a chance experiment, we've talked about an event, and we've talked about probability. So here's another representation on our word wall for these words that we've already captured. And then let's go back to revisit our goals for today. Our goals were that we were supposed to be able to explain whether certain results from repeated experiments would be surprising or not, and that we can estimate the probability of an event based on the results from repeating an experiment. So, your evaluation activity for today is entitled Fiction or Nonfiction. So, I'm going to give you guys about 5 minutes. We're going to pause the video here for you to read the scenario about the librarian in your student companion and answer the question that says, based on the information from these patrons, estimate the probability that the next patron will check out a fiction book. Okay, and explain your reasoning. So we just want to understand your thinking. So we'll pause here for about 5 minutes for you to answer and also submit your student companion. There were some portions that we skipped over, which is fine. We'll just give you credit for the portions that you guys are completing. Now, let's pause here so that you have 5 minutes of work time for the evaluation section. Okay. So, in the spirit of Halloween, we want to make sure that you guys have a great day. But before we leave each other, your independent activity, you will have one small assignment, which is one learning target problem that will be posted in Google Classroom. So please make sure that you answer that to your best of your ability. Remember, with our learning target problems, you are only answering the section that says the student learning objective and the problem. The second portion, the third column, you do not answer. You're only answering the first column and the second column. Other than that, I hope that you guys have a great rest of your day. We will reconvene tomorrow with a new lesson on Friday, and that will be it for our week after tomorrow. So we will see you all tomorrow.